Good afternoon, ladies and gentlemen. Today is Monday, 30th September 2024 at 4 p.m. First webinar of the week, and it's the first time we are doing it on Monday. So as I said, I had my own apprehension whether people will join, but very encouraging. As usual, our webinars always breaks the record. And for this session, we have almost 350 registrant. So yesterday, on Saturday, we had a webinar on lightning protection, which had a record attendance of over 800. So, our webinars are quite successful because every time it always surpasses the previous records. So I'm welcoming you all for today's webinar. And this webinar is powered by, or I would say our technology partner is Emirates Safety Laboratory, one of the largest laboratory in Asia, one-stop testing laboratory and certification body based in Dubai with strong expertise in fire protection requirement. As a testing and inspection and certification, in short, it is called TIC entity. They cater to a diverse range of industry sector and a variety of standards and regulation. Therefore, they play a critical role in economic field related to active and passive fire protection system and facade. So, ESL offers wealth of technical experience and expertise in fire testing, performing laboratory, on-site testing for various manufacturing and process industries. And they work hard to help you go through the various testing and assessment of the evidence of compliance of the product against applicable standards and specification. That's our partner, ESL Strength. So today's topic is about fire door, but bi-directional testing. My name is Dominic. I'm from the fire industry over 35 years. So I'll be your host for the session today. So we are excited to have you as we dive into some of the most critical aspects of fire safety, particularly how bi-directional testing of fire door plays pivotal role in ensuring fire containment and overall building safety. In India, fire door is mandatory for all the high-rise building. And not many as a end user or the user of the property understand what is fire door. What is the critical role of the fire door in their building? Because it's mandatory, they have a fire door. But how much are they aware of this fire door? So in today's significant bidirectional testing and why it is essential in today's fire safety landscape. Very unfortunate, we had a couple of major fire. Just 2 days back, we had a factory fire in Hosur, where Tata Electronic factory, where they house over 3,000 employees in that structure, got a fire. The entire structure got damaged. So we are trying to find the reason of it. We are trying to discuss this on 4th. What are the causes of this fire? Where are we missing? So, and also today our Subramaniam, the speaker, will talk about an overview on relevant standard, testing method and practical implication of fire door. The webinar is designed to help professionals, and it could be architect, project manager, consultant and the end user to understand the critical importance of the fire door in controlling the spread of fire and how right testing methods can strengthen this line of defense. The specific reason for circumstances call for these tests. Test has to be done, but on what reason, what circumstance this test has to be done. So throughout this session, we encourage you to engage our speaker, ask questions and share your insight. So I would request all the participants who are there, please use Q&A box down when you are viewing this webinar, below the screen you may have certain menu. In that there's a Q&A box. Please post your questions in that, so that it will be easy for us to take up those important questions. Meanwhile, our moderator, Mr. Mrinal, try to answer on the online, and some of the important questions will be left there. So I will take it up at the end of the session. So I would like to introduce our moderator, Mrinal Sapru, with so much experience in the testing and inspection on passive fire product. He has a very rich experience over 18 years in this industry. So he will be talking to us. He is the regional head of ESL. With me, the expert today is Subramaniam Shivalingam, a highly skilled resistant to fire testing engineer at Dubai Civil Defense Emirate Safety Laboratory. He brings wealth of knowledge and expertise to his role. Mechanical engineer, he established himself as a specialist in fire testing methodologies throughout his career spanning over 8 years. As a resistance to fire testing engineer, Subra plays a pivotal role in evaluating fire resistance of various materials, structures, and systems. His meticulous approach of testing to various international standards such as BS, EN, ASTM, UL, and Indian standards ensure that building infrastructure and products adhere to rigorous safety standard, enhancing overall fire safety measure. So, ladies and gentlemen, that's introduction of. Let me unshare this. Hope my screen is unshared. Yeah. So, screen has stopped shared and window is closed. I would like to welcome Mrinal Sapru to speak about, as a technology partner, as a knowledge partner of this session, how the participant will be benefited out of ESL webinar. Over to you, Mrinal.
Thank you, Dominic. Thank you very much for your kind words and the introduction to this whole session. Good afternoon, everybody. My name is Mrinal Sapru, and I welcome all of you on behalf of Emirate Safety Laboratory and Blue and Grey to today's webinar on navigating fire testing requirements for fire doors, along with my colleague. For those of you who may not be familiar with ESL, let me just be very brief on the introduction. We are an internationally accredited third-party testing laboratory and certification body. We specialize in fire safety of the construction products and building materials. And at the same time, our expertise in fire safety and certification is widely recognized across Middle East, Asia, and beyond. As a testing body and a certification body, our mission is to ensure a safer and more sustainable future by providing top-tier conformity assessment services, so that we help the businesses navigate the complex landscape of safety standards and different market regulations. Our comprehensive range of services include fire testing, fire resistance, and also reaction to fire for various products, including fire doors, which we are discussing today, hardware, and the complete systems. We collaborate with manufacturers, OEMs, consultants, consulting, and the regulatory bodies to ensure that the products meet local and international standards of compliance. If I talk about today's session, today we will be delving into the intricacies of fire door testing. As Dominic has rightly put, it's a very important and a critical aspect of any construction project, especially given the high rises with the growing urbanization in all the major cities across the world. So what we will be doing is we will be covering the applicable standards, testing methods, and their compliance requirements. Fire doors are, as most of us know, that they are a critical component of any building's fire protection system. They act as a primary barrier to prevent the spread of fire and smoke, and hence their proper testing is very much essential for maintaining the safety and integrity of the structures. Whether you're a manufacturer, whether you're a construction professional or a safety consultant, understanding the critical role that fire doors play in a building safety is vital for protecting the lives and the properties. So, in today's session, we will explore what are the key aspects of the fire door testing, why it is essential for fire safety compliance. Our goal through this session is to provide you with the practical knowledge, at the same time share insights from our experience, and help you navigate the complexities of the fire safety regulations and testing procedures which you might have come across in your day-to-day projects or assignments. Having said that, I encourage you to actively participate, ask questions in the Q&A box, and engage with either with me or the expert who will be speaking after me. By the end of the session, we will make every effort to answer all your queries, and I also hope that you will have a deeper understanding of how fire doors testing, contributes to overall fire safety and compliance. And also, you will learn that how ESL can support you in ensuring that compliance and quality. So, thank you very much for joining us today. I now hand over the floor to my colleague Subramaniam, who will then take you through the session. Subra, over to you.
Thank you, Rinal. Before Subramaniam comes in, I would like to inform Subramaniam. We have good participants.
Yes, yes, Dominic.
Yeah, Subramaniam, we have risk assessor from India. We have from insurance companies. We have project managers from all across India, and also we have people from Egypt, Middle East. There are some guests from Singapore. So this is a very important topic. I'm sure every participant here will understand from Subram. And I request everyone to post your questions, whatever in the Q&A box. Over to you, Subram. Let's begin this session with you.
Thank you, Dominic. Thank you.
Thank you.
I'll just share my screen now. Just a minute.
Yeah.
I hope everybody can see my screen. So good afternoon to one and all. So I'm really excited that there is huge people who are really interested to know more about fire doors. So today in the topic, so we are really going to discuss how bidirectional testing is going to protect lives and prevents failure, because the fire doors are really in this market, and throughout the world you have a lot of failures which are happening. So we just want to make sure that they are rigorously tested and properly installed in the site so that it fulfills its proper function. So I'll just maximize my screen.
Full screen?
Yeah. Is it okay now?
Fine. Yeah, there are, I can see some black patches. If participants continue to get any patches on the screen, then we can do it from here. But however, we'll go ahead until, a participant says it is not comfortable.
Sure. Yeah. So I'll just move. So basically, so my name is Subramaniam Shivalingam. I'm working as a fire assistant, testing engineer at Emirates Safety Laboratory, and I have an experience of more than 8 years in mainly resistance to fire. So today in this session, we are going to talk about what are the various fire testing standards for the fire door. I have already done one more one more webinar in the past, which is clearly explaining what are the various parameters, how the fire doors is assessed based on various standards. So now in this session, we'll mainly cover only about the bidirectional testing and what are the various threats in these real world scenarios, what we come across. So I'll just move on slide by slide. Now this is my introduction page. As you all know, we have come across this Fire Door Safety Week 2024, which was last week, 23rd to 27th of September, which is mainly focusing on a theme of a false sense of safety. So that is clearly stating that we have everything in place, but we don't have a proper output of the fire door, and still there is a lot of fires happening then and there. So it can be because of many parameters like human errors, or it can be because of the way they're getting installed, and there are several things which we will go across each and every slide now. So basically, we need to know what is the function of a fire door. The fire doors are designed to resist the spread of fire for a period of time, like example 60 minutes or maybe 90 minutes or maybe 1 hour, like that. So mainly the function of a fire door is to allow the egress from a space and to close once released. So what it's trying to tell, it should be operational in one way to allow to egress from one space to the other space and to get closed by itself once released. This is the main function to maintain its like fire rating capability. And the next function is like protect escape routes from effects of fire, smoke, gases, flames, and so on. So this is also one other main thing. Then you have the third one, which is like potentially to limit the amount of oxygen available to slow down or stop the spread of fire. So fire door's function is to keep it closed and avoid the supply of oxygen from one place to the other place so that the fire spread can be like heavily stopped. Then moving on to the next thing, these are the various fire testing standards for fire doors, which is available and which is like most famously like done throughout the world in more quantities. And so here you have like BS 476 part 22. As you all know, this is going to get closed over a period of time because this standard is like already withdrawn and it is almost to be stopped like after a period of 5 years as per the approved document. But still there are so there are some building codes still having this standard. Maybe they need to like decide to take it forward or not. And there is one more like European famous standard, which is EN 1634-1, which is also related to doors, windows, and everything. And the Indian standard, which is IS 16947, which is mainly related to doors with glazed panes, openable glaze, and sliding glass doors. And the other Indian standard is IS 17518, which is related to like timber doors and metal doors, which is the same as ISO 3008-1, which is an international standard. And you have the American standard here, UL 10C, which is related to positive pressure fire doors of the door assemblies, and several other standards which are like less often tested, which is UL 10B and NFPA 252. So with reference to the definition of the door is it's really very important because they every like many people have different interpretation, like what is the definition for each and every door. So they just interpret the standard. So I want to like emphasize that they are properly they understand the definition of each type of door. It's very easy to understand the doors, which is timber door with a timber door frame, which is very clear. And you have the other type, timber door leaf with steel door frame, which is also clear. And uh, like out of this four, the main interpretation where it comes is the steel door set and a glazed door. Steel door is nothing but a door or openable window with a leaf constructed using a steel facing sheet, and for which the hinges or pivots are attached directly to the steel leaf, which may be prepared to incorporate a glass or vision panel. A small, so you know, like on the right, you have a like image which is having a steel door with a small vision panel, which is called as a steel door, just to show you what is a steel door. But whereas a glazed door is called a glazed door, even though it has like metal framing, it is not a single skin layer, so it has like metal framing along with the glass. So this glazed door is defined as like doors or openable windows with leaves constructed with a proprietary steel or aluminum, like using profiles designed to incorporate glasses or panels, where hinges or pivots are attached directly to the metal profile. So this is the difference in this like in this type of like doors. You have major part of the construction is glazing, and you have the metal parts only along the like latches and along the hinges and so on. So this is the major difference between a steel door and a glazed door with metal framing. So as you can see, they're next to each other, they're totally different. So each and every door shall be assessed based on the type, configuration, how they're installed, and so on. So as you see below, the different door sets have different approaches. So each and every door doesn't behave the same way as the other door. So we need to assess the door based on the type, and this is really very important. So that is why I want to bring this definition to you all. Now, the significance of bidirectional testing. So this is the major topic and very hot topic. Everyone is really interested to know, because everyone in this market mainly thinks that testing only from one side will give the other side. So this is an interpretation throughout the world. Even still, we are also trying to get this clarified as we are part of as we are part of eGolf Laboratories. So we are also trying to get this sorted. So as a like the major significance of a bidirectional testing is that bidirectional test is aimed at replicating and building fire attacking the door from either direction, the opening in, which is a push side, or opening out, which is a pull side of the door face. So when simulating a fire attack from either side of any door set, the design requires testing two intact samples or two individual samples of each model. So then only we can be sure that when there is a fire from the other side or from inside or outside, the fire door can like perform well to fulfill its function. So as you all know, why, so you might all have a question, why is a bidirectional testing required for fire doors? So when a door with a frame is an asymmetrical construction and does not fulfill the symmetrical exception. So when these things are not there, then you need to test your doors from both sides. And so this is the main reason. So when a door can be tested only from one side, so the door set shall be fully symmetrical, or if you fulfill the specific rules as per the test standard. So there are some like set of rules given with this test standard when you want to test your door from one side, or if the application itself is it's requesting the door, it is only like required to be tested from one side. So this is the main thing what you need to understand. So to understand how the specimen is considered symmetrical and asymmetrical construction, we can see in this upcoming slides. So moving to the next slide, like, do you know why any door set need to be tested from both sides? I'm just wanted to like emphasize the same question again, because the performance and the behavior of a door are not the same when exposed from each direction, because each and every door's arrangement like while testing the frame like lies to be on the fire side at when it is opening like away from the furnace, whereas when it is opening inside the furnace, the frame is exposed on the non-fire side. So mainly the fire doors are like made up of many engineering elements. It is also affected by various parameters. For example, a door is getting installed in a frame for testing or anything on the real side. It has many like like behavioral effects because of these parameters, like supporting construction. When it is installed in a solid or an AAC like blockwork or a flexible drywall blockwork, it has a different behavior. When if there is any change in the type of the door set material, if it is a steel, timber, or glazed metal frame, each and every material have their own like behavioral like changes. It will affect the door, and the type of hardware being like used in any door set, it's concealed or surface mounted. Each and everything will have different behavior, and it will have its own like effects during a test. And also the location of the hardware, if the hardware is really fixed, offsetted from the leaf or the door frame, or if it is fixed exactly in the center of the door leaf or door frame, these also matters. And also the other parameters like the weight of the door leaf, if the door leaf weight is really high or low, it also depends how the test results will give us an output. Also the retention force from the door closer is also a main parameter which affects the performance and behavior of the door. And it mainly like as you see, like many of the fire doors of timber kind are always like installed with only a foam, not with any fixing screw. Without a fixing screw also there can be like different effect, and with a fixing screw can also have a like different effect, because under fire, when it is getting exposed to heat, it can have the deflection or this bending movement or bowing movement because of this fixing method also. And also it relates with the expansion rate of the intermittent or hardware protection liners. So like during a fire test, if this is getting expanded or it is not getting expanded, is also going to affect how much the leaf and the other parts of the hardware is going to behave during a test. Moving to the next slide. Here, as I told you in the previous slide, there is a lot of like movement or bowing happening during a fire test. So here in this, we are going to see what will be the interaction between the fire barrier, which is the supporting construction or a drywall, and the door frame and the door leaf. So what will be the performance and behavior of a timber door in timber door frame opening towards fire, that is like opening into the furnace? In this type of phenomenon, the door leaf tend to bow towards fire due to shrinking. During a fire, it tend to shrink slowly because of because it is a wooden door, and then it moves away from the doorstop, which is when it is opening inside the furnace, the door frame is on the other side. So it is moving away from the doorstop or door frame rebate, which is causing easily it to bow towards fire, and there is no support for that to hold the door leaf there. But the larger door frame will not have a big movement, but slightly it will have a movement depending upon the fire barrier, or like depending upon what density of this fire barrier is being used, which can be an AAC block of 500 kg per meter cube, or it can be even a solid block. It depends on the fire barrier, how flexible it is, how stiffer it is. If it is really stiff enough, the frame might not move heavily. If it is not stiff enough, the frame can move along with the door leaf, which is good for the test. And mainly under this condition, it really makes the door leaf to bow heavily along the top and bottom edges of the leaf. As you see on the figure on the right, there is a figure, it's showing the door frame is really straight and the door leaf is tending to bow like heavily along the top and at the bottom as well, which which will be aided by a positive pressure condition inside the furnace. So this tends to push the flame out of that gap. So that is why this condition, opening into the furnace, is considered as most onerous condition for integrity failure. So in the same way, what will be the performance of a timber leaf door in timber door frame? In the same case, as you see, when the door leaf is opening outward the furnace, the door leaf is going to get bow at the same way as it is happening when it's opening inside. But only thing is that the door frame stop or the door frame rebate is going to support it at the middle. So while it is opening outside the furnace, that is why this case is called not really more severe than opening inside. So now we are going to the next type of door, which is the metal leaf metal door frame. What will happen when it's opening away from the fire? Because I want to consider only the most onerous condition. So when this metal leaf metal door frame opens away from the furnace is considered more onerous, because the door leaf tend to bow away from fire due to expansion of the metal. The metal tends to expand during a heat, but the larger door frame will not have a big movement, but slightly towards the fire depending upon the fire barrier stiffness or flexibility, so on. Under this case, you just have it moves away. As you see, it moves away from the doorstop or door frame rebate. So in this case, you have a condition that makes the door leaf to bow heavily along the top and bottom the same way as the previous one, but in this side, but in this case, it since the door is opening outside, the top and bottom edge tend to bow outside the furnace, which makes it to push the flames out at the top, aided by a positive pressure condition which is maintained inside the furnace. So for a metal door with metal door frame, this condition of opening outside the furnace is considered most onerous. But these all are the condition what is happening during a fire test, but we need to know what the standard is telling about the condition and what should be fulfilled to get a fire rating for both sides. So in this further, I just wanted to make sure the cases what we discussed in the previous slide is all talking about the integrity failure. So none of the parameters considers about the insulation and the radiation. So during the fire condition, the weakest direction, where for a wooden door example, it's opening inside, direction of exposure of fire is not necessarily the same for all types. As you see, each and every type of door behaves differently. So each and every type will have different effects and performance. So it is not necessarily the same for all types. And during an assessment, we need to consider the weakest side separately in the terms of integrity and insulation performance. This is not necessarily the same result for integrity as well as insulation. So therefore, each type of door shed shall be assessed individually. As you see in this image, you have a timber door leaf and a metal door frame. When it is behaving in a dry wall, it is more severe than in a solid or rigid supporting construction. So these things under this condition, the weakest side of the door set will not be the same for integrity and insulation. This is what we are trying to emphasize. And the influence of the wall, which is the fire barrier within the doors or installed, cannot be omitted because they are all part of the assembly. Assembly is considered a supporting construction, and the door leaf, door framework, and fixing method, and each and everything throughout the test frame is considered as an assembly. So it can never be ignored the fire barrier cannot be ignored, and each and every direction of opening will have different effects for integrity, insulation, radiation. So that is why the standard codes are emphasizing that they all the doors that are that are to be fire rated from both sides, not only from one side. So moving further, so Arya, can you move to the next slide? So moving further, so we need to understand what is symmetrical condition and what is asymmetrical condition for a door set. So here in the image, you can see an example. It is a pivoted door, which is when you see them when viewed in plane along the door set's construction, it is totally identical along the right side as well as the left side. I mean on like on both sides. When you see from the plane that the frames are really symmetrical, and the door leaf, the intermission strip arrangement, all of them, the architraves, they all look the same. It looks like a mirror. So this is how a symmetrical door needs to be like assessed, if they're really symmetrical or not. If they are not symmetrical, then they need to know how the type of door the door need to be assessed. And like basically in a door, the major thing which is really important that it needs to be followed is the fire stopping, because the fire stopping is part of the door assembly. It is really maintaining the door to keep within the opening with any example like a foam or sealants, which is really helping the door to keep it in place throughout the test, and also the fixing screws whatever is being used. So it is really important that anything what is being used for testing should be the same in the real installation, and the only fire stopping system that can be used is the one tested together with the door set. So it is the most important thing for a fire door. Otherwise the fire door will not be in the position and it can have severe effects. So now we understood how to see a door, is it symmetrical or not, by drawing a center line along the cross section of the test specimen. So when viewed in plane along the cross section, the door set construction is identical on both sides of the center line. So the rules for asymmetrical construction are given in the next slide, so which we will see now on the next slide. So now these are the major rules given by the, like, okay, let's put it like these are the minimum rules given by the standard, so that any asymmetrical construction that needs to be tested only from one side, so as to follow the table given in EN 1634-1, as well as there is a table mentioned in the Indian standard, which is IS 16947, which is for the glazed doors and glazed like windows. So as per this standard, what are the minimum standards they are giving is that the first rule is each of the door leaf is of symmetrical construction except for the edges. So in this, they're telling that if a door leaf and door frame is there, of course they're always, most of the time the door leaf and the door frame are symmetrical because of their rebated construction. So you can exclude the edges. This is the first rule it is just giving you, so that the lock or leading edge and hinge edge or the double rebated door edges can be excluded. All the edges along the leaf and the frame can be excluded. But if you exclude that, you should have a proper evidence, or any restraining or supporting element of building hardware evidence should be produced, which was tested as per Indian standard or as per the EN 1634 standard when exposed in both the direction. So you need to have historical evidence that you have the hardware evidence, whatever is being used for the test is all provided with the certificate and the hardware like test certificate as well. And you should make sure that there is no change in the number of leaves, or mode of operation cannot be changed. If it is of such kind, then it cannot be taken forward as a single test. So this is one thing: sliding, swing, single action or double action, this action cannot be changed, or this number of leaves or mode of operation cannot be changed. Then the last thing, if you have a door or a glazed door having or a timber metal leaf door having a side and overhead panel, so these can be excluded, and if they are not even like fully symmetrical. And if they're symmetrical, then there is no issue with that. And basically this Indian standard, which is IS 16947, is also like saying the same thing. You can exclude the edges, and the only difference between Indian and this European standard is that they have a special requirement having all the elements of the building hardware having a melting point of not less than 1000 degrees, or the element of the building hardware previously satisfied as a test like with the test done as per the Indian standard. So this is the like major difference between EN 1634-1 and IS 16947, and there is no other major differences. Out of this, if you will fulfill all these minimum requirements, then your door can be tested only from one side. So like most of the thing what we see in the market is none of them have their hardware evidence being tested from both sides. So end of the day, they just end up with testing from both like two samples, one opening inside and one opening away from the furnace. So these parameters, if they're fulfilled only, you can test only from one side. Then only the table 2 is applied for the doors. So can you move to the next slide, Arya? So in this, you see a table from the standard, which on the right, you can see the table 2 from 1634-1, as well as on the bottom of the screen, you can see table 2 from IS 16947. So as per EN 1634-1 and IS like 16947, like requires two specimen to be tested, one from each direction, unless the element is fully symmetrical. As you see in the previous one, a pivoted door was fully symmetrical on both sides. So it is really important for us to check if they are really fully symmetrical or not. Otherwise, if you test only from one side and if they are being installed in the side condition, the door may behave totally different when it is tested from other side. So it is really important, and it is emphasized by the standard and code and like code requirement also, that it shall be tested from each direction. So main purpose of the fire door is to behave or protect people and egress and so on so things from both sides, not only from one side. So in this table 2 may be used if the door set is asymmetrical, but door leaf is fully symmetrical. So under the additional rules of testing, if they fulfill, then you may test only from one side. Otherwise, it may not be able to test from one side. Okay, that's it. So now we move to the next slide. So Arya, like, can you go one like previous slide? One more thing I missed. Can you go to the previous slide? Yeah. So under this table 2, if you can see, the table is talking about a hinged or pivoted door or a hinged like metal frame door. Out of this table, so there is no information that it is talking about a fully glazed door. So this table is not applicable for fully glazed door. It is only applicable for like timber doors, metal doors, or some other products like rolling shutters, sliding doors, and operable like curtains. Under this, if you need to fulfill integrity, insulation, and radiation for a timber and metal door, it depends on this minimum rules. If you fulfill the minimum rules and if you test only from opening into the furnace, then you can cover the other side for integrity, insulation, radiation. Whereas for a steel door, you will only cover the integrity and radiation. You will not cover the insulation unless it has been tested from both sides. Whereas here you can see the hinged metal leaf metal frame is only opening away from the furnace is required, but under this, the doors will get the criteria for integrity and radiation if there is no insulation inside the material. If there is any insulation in the material, then the door needs to be tested from both sides to fulfill the integrity and this radiation criteria. And it is very clear that the Indian standard and this European standard does not talk about the fully glazed door, so they totally does not belong to this table 2, and they must be separately assessed based on their conditions and how the construction is. Then based on that, it shall be if it unless it is fully symmetrical, it can be tested with one test. If they're not symmetrical, they need to be tested from each side to assess the fire rating for each direction. So we can move to the next slide now. So basically, this Indian standard for this timber and metal leaf doors, which is IS 17518 or this international standard 3008-1, is mainly talking about the number of specimen by which you can determine you want to test only from one side or from other side based on the Indian standard. So what IS 17518 is talking about, the number of test specimens shall be selected as described in ISO 834, which is referring to other international standard, which you can see the screenshot below. If the testing is carried out from only one side, it shall be stated in the test report whether this is due to symmetrical nature of the door, because it is by application itself, it is required to resist fire only from one side. So this is the main thing. So when you go into ISO 834 screenshot, it is talking about the number of test specimen at least one specimen for each specified support or restraint condition shall be tested. So when a separating element of asymmetrical construction is required to resist fire from either direction, the test specimen representative of the construction shall be subjected to fire exposure from each side, unless it can be established that the fire exposure of particular phase will be more onerous. But no laboratory or no consultant can tell that this is more onerous, this is less onerous, because as we saw, there are several there are several parameters which is affecting the door to behave differently. So we can be never sure that which is more onerous side. Only we saw the interaction between a door frame and a door leaf, but there are several other engineering components involved in a fire door which will ask the door to behave totally different unless it has been tested from both sides. So it is very clear that the separating element shall be tested from each direction, and and we cannot assess or do analysis that it can be more onerous from this side or from that side. So it is pretty clear in this scenario for the Indian standard. Let's see how about the other British and American standard talking about. So whereas the testing requirement for a British standard, as we saw this BS 476 part 22, which is also telling the same. For vertical asymmetrical separating element that are required to resist from either side, the element shall be tested from each side using a separate specimen. However, if it is possible to ascertain the direction of exposure that will give lesser fire resistance, one test may be carried out. But we don't know how the performance will be there for the other side, because we have seen many examples where while testing the fire doors, even the door opening away from the furnace tend to fail and have shorter or maybe lower rating than the door opening inside the furnace. So it also depends upon how the specimen has been installed. The workmanship of the door is also very important. So in this case, you can never assess which is more onerous or which is more weaker side. So end of the day, as per the above requirement from BS 476 part 20, it does not give you the procedure how to assess the weaker side and how the laboratory can assess the weaker side. So it is very clear that the door set need to be tested from both sides to identify the weaker side. Unless and until it is tested or you have any historical evidence, it can never be assessed without any proof to go forward. So to satisfy the fire rating from both sides, it shall be tested from both sides. When you look at this American standard, which is UL 10C, which is a positive pressure test method for fire doors, and like under this, it has a very clear requirement for swing doors. It can be tested so as to open into the furnace to cover the both sides. But this is only for the door set. But when you want to assess a door hardware under this American standard, it is telling to evaluate the door. So it is telling, but when the door hardware is to be evaluated, like fire exit devices, door closers, hinges, latches, mortise lock, and so on, so things, it needs to be clear. Then it is clear that the door set need to be tested from each direction so as to fulfill the requirement for the hardwares. So moving to the next slide, we can see. So now there will be a lot of clarifications with many people who are testing the doors. What will be the result when you test two doors? So in this session, what will be the product rating for the door that are being tested bidirectionally? So the clear answer is, for example, you can see the figure here on the right, which is an image showing a door testing on the left opening away from the furnace and the door on the right opening inside the furnace. When you do such a test, then out of this two, the lowest rating, whichever is, for example, let's say on the door on the left is getting like 60 minutes and the door on the right is getting like 58 minutes or something, and this is a 60-minute fire rated door. So out of this two, the lowest rating or the lowest classification period will be taken for this as a product rating. So as per EN, if it fails at 58 minutes, the door on the right, the classification rating will be EI45. Or as per Indian standard, it will just get 45 minutes or whatever is the completed minutes according to the classification time. So it is always the lowest rating or lowest classification period will be considered when you test both the door, because the door opening outside, door opening inside, they are not the different. They are a product. As when you see as a product, the product rating will be considered as well, like always the lowest rating or the lowest classification time, whatever is achieved under testing. So it is really important that the fire test shall be tested from both direction to fulfill the requirements of the test standard due to the asymmetrical construction, because almost 90% of the doors are asymmetrical in construction, because of their design. So it is a responsibility of the fire door manufacturer to design and get their product assessed to perform their function of fire door from both sides. So we'll move to the next slide now. So we need to understand what are the various parameters or various threats in real world scenarios for a fire door, because we as a testing laboratory, we have some set of verification procedures from the test standard to check how the door leaf or the door frame or how it is fixed to the supporting construction and so on. So when we verify all these things and we get them into the test report, so these are really very important for a fire door, how it should be installed. And end of the day, we make sure that the drawing is also converted to the product what has been tested in the laboratory, so that the technical documentation or technical procedure that are required to be attached to the test report are thoroughly checked from our end, and how the door is being installed inside based on our verifications. So we bring all these inputs into the test report. So it is really important for any door installer or door manufacturer to check these parameters are really fulfilled as tested. So I have listed some of the parameters which is really important when a door is getting like installed in the site as tested. So the first major thing what I would like to highlight is the fire stopping. Fire stopping is nothing but the gap between the supporting construction, which is the wall, and the frame or the subframe is getting filled with a proper fire rated material as tested. Whatever is getting tested should be used inside, as we see in the previous slides. It is really important that the fire stopping is really important to help the door keep in place within the opening. So it shall be tested, it shall be tested with a fire fire stop, and the same should be installed inside to fulfill its function. And mainly we also record what is the type of wood species being used in the site based on the inputs from the manufacturer or the customer here. So it is really important that the wood species cannot be changed from what was tested, and the density of the door frame or the door leaf cannot be changed from what was tested. It cannot be lower than what was tested. It can be higher based on the XAP and this DAP, this direct field of application inputs from our test report. And the intermittent strip, there are some specific type of intermittent strip materials for fire doors, which is one is called graphite, and you have some other trade names also for this intermittent material. So it is really important that the same material is being used for the fire door, because this is the only protection which is going to prevent the door's movement, as well as which is going to prevent the smoke from coming from one side to other side. If this is not the same material as installed, the fire rating of the material of the door will totally drastically change. So it is really important to use the same as tested protection materials. And the hardware location also, we feel that we really mention these hardware location of the door in the test report. If that has been changed also, it can be a very risky for the fire door to fail faster than how faster than what was tested in any laboratories. So, and the next thing is lock set or hardware cutout. We clearly mention what is the size of what will be the dimension of the hardware, what has been tested. If the cutout was taken bigger than the hardware dimension, this can also have a big effect on the fire door. And the hinges type cannot be modified, because for example the door has been tested with a concealed hinge, and if you change the type of hinge, the behavior of the door will change, and the fire rating of the door also will change. So it is really important that when you change any material during for the fire door, it shall be tested again to fulfill its function of whatever the fire rating for that door. So it is very clear that you cannot change any material, you cannot change any type of the hinge or so and so materials, so that if you pull anything out, the fire door is going to behave totally different, and it will not fulfill the required rating. And you cannot also reduce the number of quantities then tested, because the direct field of application which you're going to see in this upcoming slides is giving you an option that you can increase the number of inches then tested, but you cannot reduce or you cannot change the location of the inches from where it was tested. and you cannot introduce any new material then that was tested, because when there is any new material getting involved, it can have its own effects on the fire rating. Also the frame fixing method, the frame fixing, like as I told you, there can be only foam is being used in some like door or some fire doors, and there are some people who are using foam with the fixing screw. So the same condition what has been tested, how the door has been installed, should be done in the real world scenarios as well. And regarding the glazings, for example, a glazed door of such kind, the major part of the glazed door is the glazing. If you change the type of the glazing, for example, the tested type is maybe like tempered glass, the glass where the glass type cannot be changed, it cannot be changed from what was tested, and the thickness of the glass cannot be modified, and the rating of the glass also cannot be modified, which is the product like rating for that type of glass. It's really important. No changes can be done from what was tested, but you can do some allowed changes based on the XAP standard, which is called extended application standard as per EN, and also based on the field of application, which is called DIAP in shorter. So these like certain modification can be done, which is clearly mentioned in the test report. No other further modification or no other further interpretation can be done. So that is why we clearly mention what is allowed, what is not allowed in our test reports. And coming to the last point, the permissible gap. The gap is very important for a fire door, and the door closure retention force is also important, which is also measured in our test reports. And these things should also be taken into the consideration when you are installing a fire door. So that's it. We move to the next slide now. So we just concluded how a test should be done and how a bidirectional results you will get based on a bidirectional test, and what are the rules you need to fulfill. Now after you do a test, you get some test results. So based on the test results, you have an allowed changes or modification that can be done based on the direct field of application. This is applicable as well as to the Indian standard, and this is applicable as well as to the EN standard, because Indian standard has taken most of the reference from this European 1634-1, and you have many changes that can be modified. So speaking about this, you have a figure at the bottom left corner. I already highlighted this in my previous webinar also. You have an AAC block installed on the right corner, then you have a solid block installed at the bottom corner. So such conditions are seen in the site. So these conditions will have a big impact on the fire door or the deflection moment of that wall and so on. So it should be carefully installed in site, so that the same function or same results what you get from the laboratories where it is getting tested to the site condition. So none of them can be changed. And you have this non-standard supporting construction for any glazed door. Most of them will have a side panel, overhead panel of glazed type. So these parameters or these partition wall, let us call it a partition wall along the top and the bottom, these cannot be tested along with the door. So the standard is very clear that the fire resistance of any supporting construction which is non-standard, so this is called as per the standard associated supporting construction or non-standard supporting construction. So these things cannot be tested along with the door set. This is what the standard is very clear. So any glazed door manufacturers who are here, just to understand that any door set that need to be tested with associated construction, the associated these overhead panels or side panels shall be tested as a partition wall well in advance from each direction, depending upon is it symmetrical or not symmetrical. Based on that, with that evidence only, you can go forward for any single door or double door test with that figure of with that image as you see here, which is marked up. And now talking about the supporting construction, you have two types of rigid supporting construction described in this Indian and the European standard, which is AAC, which is having a 500 kg per meter cube, and concrete blocks of solid type, which is having a density of 2400 kg per meter cube. Out of this two, if you test your construction with an AAC block of softer block work, you can also get the test results applicable for the concrete blocks as well, based on the direct field of application. And also you can test your doors and also with flexible drywall construction. Then if you test them with a drywall construction, then the same applies for the AAC as well as concrete blocks, which is the advantage when you test with EN or Indian standards. Like moving to the next slide, we will. So in this slide, as per EN 1634-1 clause 13 and the IS standard, Indian standard 16947 clause 12, the direct field of application test results defines the allowable changes. As I told you, in the test report itself, you can find the allowable changes to the test specimen following a successful fire resistant test. So these variation can be applied automatically without seeking for any evaluation, approval, or any calculation from the certification body based on the test report. So what are the various things that can be changed? So it is listed here, the material and construction. As I told you, the material and construction of the door set cannot be modified as it has a big impact. So it can never be changed, whatever is being tested. Only what is tested can be used in the site for the material and construction for timber or metal construction. Whereas glaze construction, for example, you have a vision panel in your door leaf, and after a successful test, the standard allows you to increase the vision panel size by 25% based on some minimum like size requirement as per 1634-1 and as well as IS, this Indian standard. Based on, if you have a vision panel and it is getting positive results, you can increase the size of the vision panel up to 25% based on the based on that. And regarding the decorative finish, it is not really important that you need to include a decorative finish during a test, and it can be added, some kind of veneer or some kind of coating can be added unless and until it will not affect the behavior of the door. It is allowed by the standard. And fixing method, for example, if you're having like 4 to 5 fixing methods, and you can increase the number of fixing, but you can never like reduce the number of fixing. And regarding the building hardware, the standard is very clear that none of the hardware can be modified unless and until they are really totally the same from what was tested. But even though if they are totally same from what was tested, the dimensional things are same, it has to be like evaluated with the certification body, or whoever inspects the door, or whoever just evaluates the door and provides certificate. It has to be consulted with them for any changes with the building hardware, and it will be clearly stated in the test report. And regarding the permissible size variation, the standard is also allowing you to get, when you have a positive result, it tends to allow you to increase your size and decrease your size based on your rating. For example, you're testing a 60 minutes door and you get a test result for 68 or 70, which is called overrun A and overrun B. Overrun A is nothing but the classification time, as you see in this table, 15, 20, 30, 45, 60, and overrun requirement is also stated here, like if you test a 60 minutes door, if you get anything more than 68 minutes, then it gives you an option to increase the size of the door by 15%. I mean, increase the height by 15% and increase the width by 15%, and it should not exceed the area of increasing by 20% based on this achieved fire rating. Whereas if you achieve only classification time, which is category A, then it is allowing you no size increase is permitted, but you can reduce your size by 50% in width and 75% in height. So by this option, before doing a test itself, you will get to know what size you can get and what you cannot get. And this, for getting a proper answer, you need to wait for the test results. Once the test result has been achieved, it gives you an option that you can reduce the door or you can increase the door. So this is explained here for category A and category B. And whereas the supporting construction part at the bottom, at the very bottom, it is telling you clearly that the fire resistant of a door set tested in high or low density rigid cement supporting construction as specified in 1363-1, or as well as per IS 16947, it is allowing you to use AAC to solid. But when you're testing a solid block work, you cannot take it for consideration to install with AAC. This is the limitation for this. So we can move to the next slide now. So also I've detailed some of the DIAP based on this timber and metal door leaf standard, which is IS 17518, which is also the same replication of the European things like material, timber construction, glaze construction. It is more or less they are totally the same. you can test an AAC and you can get solid block work, whereas you cannot test a solid block work and you cannot install it in an AAC. The timber construction, metal construction cannot be changed from what was tested. The glazing can be increased. So they are more or less the same. So I just want to highlight you have the same features or same like advantages by testing the Indian 17518-1 standard as well as EN 1634 and IS like 16947 standard. So they have the similar thing, but whereas the supporting construction part, it is very clear that the choice of standard supporting construction shall reflect the range of intended use for the door. So you have to make sure that whatever is your application in site, you have to decide well in advance what type of supporting construction you need to go for, so that you will have more advantages then you have more limitations to install in the site. I think we concluded almost, and we are in the last slide, I guess. Can we move to the next slide? So we are done with the webinar, and if you have any doubts further, so we can discuss in this Q&A session. So I will leave it to Dominic now. Yeah.
You know what? He's sleeping.
Okay, hi, Subbu.
Yeah.
Thank you so much. Hope our Arya is put up Subramania's mail ID or Mrinal mail ID to contact. Why this blank? Can you unshare? Can you unshare this and make all participant view? Yeah. Yeah. Arya, could you please mark, show the mail IDs of
Yes, sir.
Mrinal for any for technical questions? I would urge
Yes, yes, sir.
all the participants to post your questions on the Q&A box. I will just take it is 5:06. We have 15-20 minutes to take up questions. So just quickly, because some of the questions are need to need not to be taken because very simple question. So our Basuraj is asking, our metal doors are 9-year old.
Okay.
Is there any option for repairing? I don't know whether
Repainting.
repainting. So what is that?
So
Subodh, to you. Yeah.
based on this, like we need to see how the test report like tells, or what are the option it gives. If the paint will not have a big effect, so we need to see the test report. Based on that only we can give an answer. Is it allowed by the standard or not? And we need to know by what standard the door has been tested, so that we can give him a proper answer for that.
Okay, Basaraj, maybe you can write to Mrinal or Subra, they'll get back to you. Sarath Kumar is saying that I doubt that any combination would result in a fire due to short circuit because the hydraulic motor inside the oil storage tank for lubrication.
I think this is not related to fire door.
I
Yes.
know. Fire duty. I don't know, Sarath. Your question is we are not talking about fire due to short circuit. I don't know. Your question is not relevant to this subject today, so I will skip this question and move on to mail. Yeah, Anup, Anup will get back to you. You are given your mail ID.
I think Dominic, this is there is one question which says how to fix fire stops at the bottom.
Yeah, how
Tara.
to fix fire stop at bottom.
Bottom for
Tara,
any
yes,
fire
Tara.
door, you have a sill at the bottom. That any mobile component, you will not have any fire door, like any fire stop at the bottom. So it is some partition or something else, I guess. What they're trying to ask.
Fire stop at bottom. Hmm.
Bottom of frame, or what they're trying to ask. I
Yeah,
don't understand.
Mr. Tara, can you be give little clarity how to fix fire stop at bottom? Is it on the frame or on the door? If you can just get back to us with more clarity on the question, we'll appreciate. Vijay
Yeah.
Kumar is asking, are the fabricators allowed to use an equivalent hardware, especially essential hardware such as hinges, closer, and locks, than the actual brand that was tested, as long as the dimensions are similar or lesser than tested hardware?
But the thing is, Dominic, if they are going to change the hardware, they need to
Yeah,
get in touch with the certification body, whoever certifies this
yeah,
door, because there are several
correct.
parameters. Like if you change the hinge, that hinge, what they're going to change is can take the load of the door leaf of same type or not. There are several things, and the location, and there are several parameters involved. So they should always assess with any certification body who certified this door, then only they can change. They cannot change it themselves without any
Yeah,
like
as I
approval.
know, you cannot change the
Anything from tested.
hardware or yeah accessories because it is not tested. So I don't think
It has to be tested
how it
again
will
if
work.
they want to have any
Yeah,
changes in the door set. Yeah, that is
correct.
the correct answer.
Yeah, Manish Kandelwal is asking what is crucial if any fire tested properly, but not installed properly at site, standard process as per IS 3614 2021. It's a good question. You have tested but not installed properly at site.
Yeah, this is what happening like everywhere, because we try to, as a like representative of ESL, we try to make the drawing from what was tested and some kind of technical set of procedures how the door has to be installed. If they don't follow the procedures how the door has been installed as tested, then end of the day the door will have different like lesser rating than what was tested. This is the answer for that.
So just to add to what Subra is saying, so basically, once the door has been tested properly, and then the question comes to installation, then it basically becomes the
Like
responsibility of
mhm.
the house of expertise on the site and the consultant, uh, uh, along with the authorities who actually have who provide the NOC for the site, to make sure that the installation has been done accordingly.
No,
Correct.
ideally you have applicators or certified applicators of the passive fire. It's not that any carpenter can go fix it up or your civil guys can fix it up, but these are a specialized job. So you need to
True.
get there is FCIA which certifies the
Hmm.
contractor, professional
Hmm.
certification they
Hmm.
issue. So in India also they slowly they demand only the applicators does all this passive fire product installation, and they need to have certain qualification to do that.
Absolutely. And once the installation is going on, it's just a recommendation, like or kind of a observation based on our experience, that once the installation is going on, whether it's being done by the certified applicator, even
Yeah,
that has to be constantly monitored. Should be constantly
correct,
monitored either by the house of expertise on the site, or by the authorities themselves.
correct. So Anup Chandra is asking whether testing also can be done for Windows, something which we do for fire door.
Yes. It is also possible to test Windows as per Indian as well as this European standard. EN 1634-1 is the right standard for testing Windows. Yes, we can do the test for Windows at ESL.
Yeah, Rajendra Sawant is very interesting question that is asking.
Hmm.
Fire door paint, the color is not clearly mentioned in any standard. In India, fire door label not provided as a provided in EN standard. So what's your say on that?
So he's mainly asking about about the label of the fire door. Is it right?
No, you say first is asking fire door paint. No color is clearly mentioned. Can you
Bec-
have any color?
no.
There's no standard for color.
No, there is no standard for color, but in the code you may find it how each and every region should follow based on the code in that region, because the code color should come from the code, not from any standard, because standard is really keen to know what material of the paint is being used and will it have any behavioral changes during a test or not. But regarding the color, it should come from the code. If there is no color, then it's up to the authorities to decide to keep things going forward. So we
So
cannot.
you also say in EN standard it insists for the label, but in India, fire door labels are not provided. So what is your take on that?
But I've seen in the standard that it is clearly mentioning that you should like label each and every fire door. So it is there also in the Indian standard.
Hmm. So Vinayak is asking IS 3614 is not mentioned.
No, I can share the screenshot. I've seen it in IS 3614. This is what I'm also telling you. I've gone through the standard, so I can see that.
Yeah. So, Vijaykanth, I believe he has a document to say it is mentioned in IS 3614. So, e- thoroughness and testing labs in India may be mentioned. Mhm. Okay, Praveen, what is there in NFPA and fire door? Is there any standard in NFPA which talks about fire
Mm,
door?
Yeah, there is a standard called NFPA 252 that is also for positive fire doors, and it is applicable, and we can also do the test as per NFPA 252.
So, Chakradar is asking test report for every batch will be taken. How do we do? Kindly
But
confirm.
for one type of design, we need to, like, they need to provide one type of design of the door, then it is getting tested, and for that specific door, what was tested, we provide the test report. So it depends on the design what they are bringing to the test. Each and every design, they, if it is a fire door, it shall be tested as per the code. So they test it, and we give the test report for that specific door alone, like nothing else. It's not like batch.
Okay. So Taradal has clarified how to fix fire stop at bottom of the door.
Bottom of the door, basically the door is like a movable
So
component, but the frame is a fixed component. There is no need for the fire stop to be installed at the bottom, then the door becomes like not operational. So this is, I don't understand why he want to install a fire stop at the bottom. Fire
yes,
stop
it's
is
already
something
fire door.
which comes between the wall and the door frame, just to hold the door within the opening, and the door
Yeah,
leaf should be operational. This is the intention of the fire door, or the function of the fire door.
yeah. He may be talking about the stopper. Mhm.
uh,
The stopper for the door. Fire door should not have a
should not have a
stopper.
stopper, it
It
should
should
be
be
kept
always
closed
closed.
always. Yeah.
So you can't have a stopper on
Mhm.
the fire door.
But
It's
there
not
are
the
some doors which has like self-closing ability. When there is a fire or something, it has the ability to close it like selfly with some
yeah. It's a
hardware.
demagnetized. You hold the magnet. Yeah.
Yeah.
So Naresh is asking, there is a small gap between the floor and the fire door. Is it allowed?
Yeah, this is basically allowed by the standard, because the intention of a door, like fire door, should be operational, so it can open in and out, and the gap at the bottom can be allowed by the standard, because end of the day you need to have the door operational. But during a test, what happens in this fire door is that, as we saw in this fire door like series 1, the, like, during a test, the air is being drawn into because of the negative pressure maintained inside the furnace. Then so this makes a circulation along the furnace and the atmosphere, which is really important for a fire test. So there should be a gap at the bottom as per the standard as well.
So in India, there are so many fire door manufacturers. I think more than 100,
Mhm.
200 fire door manufacturers. So what Chakradar is saying,
Mhm.
usually vendor are submitting 7 or 10-year-old report. Can we trust the same, or we need to ask them to which particular site they have obtained the certificate?
Yeah. And so regarding this question, any test report, there is some validity for each and every test report, unless and until the code has been totally changed. So we need to know what standard they tested, and it cannot be used for a period over than like 5 years. This is something common in the market. So this depends on their certification body. So it depends on the policy of the certification body. It
Yep.
keeps changing. Unless the code
No,
has been changed, then they need to do a test again with the current requirement.
So Sudhakar Verma is asking, hardware like door closer, if provided towards the furnace side may cause a leakage at the time of fire evaluation test. What hardware is recommended in this situation?
Leakage in the sense, of course, the smoke from a fire door is not a failure criteria for a door, like for a fire door. So we cannot suggest any hardware for that. But the thing is, it is
The door
nothing going to
closure
affect. It is nothing going. It is not going to affect the test results of the fire door, because smoke is not a criteria. So the leakage cannot. It's not considered for such tests.
so according to you, Subramaniam, what is the frequency of testing? That's why Venkatesh is asking.
What is a frequency of testing? We have a lot of tests. What do you mean by frequency of testing?
No, like in the fire door, Is once it is tested, it's the end of it, or do they require to test the particular next man?
No, for example, if they're testing a fire door and I would like over a period of time, you might get affected because you don't find the hardwares or you cannot repair them or it is not operational. In that case or in that stage, they need to come for like for a retest and they need to get that tested with the current material what is available in the market. This can like this is what happening like with the fire doors, like over a period of time they don't find the similar hardware for repairing, then they come up with a question, can we change the hardware? No, you cannot change it, you need to go through a test so that it has the same rating. So this is how it goes.
So there's anonymous asking, but interesting question.
Mhm.
This for the warehouse. There are
Okay.
3-frame or 4-frame. If 3-frame door, how will close the bottom area, especially warehouse?
Warehouse, but this
Not clear. The question is not
not clear.
clear.
Yeah, what is 3-phase and 4-phase? Maybe he's talking
Frame.
about
Warehouse,
the
the
rolling
width of
shutter.
the door. It cannot be a rolling shutter. Normally, what is provided in warehouse is a rolling shutter.
Yeah,
Yeah.
that is what
But you're
used.
saying there are not 3-frame door or a 4-frame door. If 3-frame door, how will it close the bottom area, especially warehouse? This question is not very clear. Even I'm not very clear. I don't know. I've not come across 4-frame door.
Yeah.
Anyway, I'll pass that.
I think Gilbert has asked a very good question.
What is the difference between what Gilbert is asking? What is the difference between BS476 versus EN1634? What will happen to a door that has been tested for BS476?
Because they're totally two different standard. Basically, BS is having a pressure condition to maintain uh, this neutral pressure plane of 0 pascal at 1 meter, whereas an EN door is having this neutral pressure plane at 0.5 meter from the sill. So they're totally two different way of testing, and the thermocouples also are also totally different. For a BS, it is a normal like bare wire thermocouple, whereas for EN it is a plate thermocouple, and it can never be compared. They are totally two different way of testing. That is why they have two different codes from British and the European standards.
So Sudhakar is asking if a person wants only the hardware to be tested to desired fire rating, is there any procedure to test the hardware?
Y- Yeah. So based on 1634-1, you can test the hardwares as an assembly. So it can never be separated from the door leaf. So when they want to test a hardware, they need to come up with a door. The hardwares are getting installed and it should be tested as an assembly. Then they can get a test report and use that test report as an evidence for that hardware is tested from one side or both side and having like having like XYZ rating. That's it. It's
So,
possible.
what is the validity of the test of particular design? Is the test to be prepared at the same of design after a certain period?
There is because standard is really not interested to jump into the part of design, so it is up to the client to design their specimen based on the application, and there is no validity of such kind for a design. So it depends it depends on the manufacturer. They want to change the design or something, or unless it is valid for a time period of whatever it is.
So, Baswaraj is asking what should be the gap between the door and the floor?
This gap is to be provided by the manufacturer. It depends on the site condition what is getting installed. The standard is not really keen to give what size should be maintained. It is telling to verify the size what is being installed. Based on that gap, it asks us to, based on some formula in the standard, to give what is a maximum permissible gap they can use to install in the site. So standard is not involved into telling what should be the gap for the specimen. So it is about the manufacturer to decide.
Okay. So, Vijay is asking for the bidirectional testing, the testing double doors cover assessment for single door?
This is allowed based on this extended application. When you test a double door, of same design can be converted for a single door based on the accept standard, but they need to first test that door. With that door as an evidence, we will prepare an extended application report based on like EN 1634-1, which is having that option. So they can get, based on the accept report, they can use that for a single door as well.
I think most of the viewers want your face to be seen, because in the frame that is only my face. So people have got fed up with to see my face. So they want
So
speaker face also to come in. Your camera has
okay,
to be down. Yeah,
okay,
camera is
now
looking up.
they can see.
Yeah,
Yes,
that
yes,
is our Subra. Uh,
yes.
there are a lot of Indians in Dubai, so I'm very happy to have
Uh-huh.
Indians are contributing. In outside, when you move out of India, most of the fire, labs and whether it is UL or something, there are a lot of Indians
Mm-hmm.
who are in this particular subject. They're taken as a profession. I'm
Mm-hmm.
happy that Subra is also getting expertise in this, and he's now the second series that he's doing. So people are
Mm-hmm.
now familiar with Subramaniam's capability and the way of presenting. That's
Mm-hmm.
the reason you'll find a lot of questions being asked. And
Sure.
so, Vijay Kumar, hope your question is answered. Limson in Colorado is asking, in the fire door of hardware such as cable passes for magnetic lock door, is there any standard requirement for the kind of cable need to be used for the automatic magnetic lock?
No, if they have a proper test report which is being tested, then that is more than enough to use that hardware. There is no specific standard to assess only the hardware. So if it is tested
The
as an
cable.
assembly, it can be used. Yeah.
Okay, it comes with the magnetic lock, the cable. The cable has to be, it is naturally tested by the hardware guys.
Yeah, by like as an assembly, it shall be tested as an assembly, and then it can be taken forward, like for the door assemblies for installation.
Okay, okay. So Vinod Kumar is asking, should the door closer installed with the fire rated door also fulfill the fire rating norms? Of course, yes.
Yeah.
Yeah, yes. Fire door closer also need to be tested. Yes.
Mm-hmm.
Milind Kadam, dent on the fire door while installing due to impact affect does it affect the fire resistant power of the fire door?
We don't know. That is what the inspection team or the certification body has to decide if the door is really like suitable or not. So it is not our call to take that. So it depends on inspection and the certification team. That's it.
Now, example, now ESL tested the particular door
Okay.
at the lab and all that. Now we back and send it to the the buyer.
So
Now,
so
while
so
transport, if the door got dent or
mhm.
damaged, how do you handle that?
What it so it cannot be accepted. This is the direct answer. Even if they want to check if the door will be really like giving the same results, we can test the door. Whatever is installed on the site, we can just test that door and get to see what is the answer. So we can never assess like doing any assessment based on the conditions in the site.
Mhm. So we have lots, two questions. One
Mm-hmm.
is Sudhakar is asking, the manufacturer gets the same design tested 10 times within the period of 6 to 7.
Mm-hmm.
Does he has to get the same tested again and again?
And as I told you, if it is like properly tested and it can be used, it need not to be same thing, like need not to be tested again and again, unless and until this test report is valid or the code changes. That is the only criteria. It depends the certification body or the code. Any changes in the code, then they need to repeat the test again for the same design even.
So I'll take the last question.
Mm-hmm.
Sundaram Chakra. A rubber flap to prevent entry of insects installed at the bottom of the fire door. Is it acceptable?
No, it is not acceptable. So you need to test that with that setup, do the testing, then only it is acceptable, because we don't know if there is any flaming at the bottom, and it can pass the flaming from one side to the other side because of that rubber. Like this is what we discussed in the slide. Any new item cannot be installed unless tested. We can never be sure. So this is the answer.
Okay, exactly 5:29. It's 1.5 hour presentations and good questions. I keep saying that, if the manufacturers from India, they want to export to UK, sorry, UAE and Dubai, ESL test is mandatory for them. So,
Yeah.
and also the ESL can do the testing as per the UL, as per the EN. So the cost remains same whether you give it to Indian testing lab or to the ESL. There's no major impact on the cost. I urge, and there are a lot of videos of ESL testing lab, the very professional testing lab that they exist in Dubai. Me, I'm sitting out of Bangalore. I'll be happy if whenever ESL wants to put up a lab or
Sure.
recognize a lab in India to test as per their this thing. So we are working towards
Yeah.
that. Rinal with me. So yes, our interest is to have some kind of accreditation of the lab for as per the ESL. So what's your plan, Rinal? A lot of questions being asked on that. They will know ESL, but they want ESL to be in India.
Yes, that is very much in the pipeline, and it's in the plan. But the any such decision has to go through a series of
Yeah.
approvals and convincing to be done. So yeah, so it's there and it's under process at the moment. I can only say that hopefully in the coming 18 months we might have something for India coming up.
So India wants you. India wants to have a professional testing laboratory here, and I'm sure that's my, being 35 years in the fire industry, something that the similar setup or maybe better lab is needed in India. It's not just one test. You need to do anything that goes into a building that may cause major. If you look at that Osur, major fire, crores of worth material lost. But there, being Tata, they had excellent fire measures, and all the 3,000 employees could be able to evacuate. There is no casualty. Everything was fine. But there is something somewhere. The hazardous area was not well protected. That's what preliminary report, but we don't know exactly. We're doing the testing and all that. We need to understand the causes of that. And based on that, we are doing one more webinar on 4th. The causes due to electrical short circuit. Is it, is it, is it that so? And why is it happening? So we have the webinar on 4th. And 5th, we have case study on Grenfell Fire Tower, expertise from insurance, everybody from facade, from regulatory bodies. So we are all joining. So please keep watching us. We'll be sending you an invite. Please do join, and
Sure.
we'll come back with ESL, another fire, rated testing methods. We will come back soon, and till then, safe living, ensure that you practice safety in your working atmosphere at home, everywhere. So I
Sure.
would like to thank ESL for joining as a knowledge partner. I want to thank Brinal and Subra
Sure.
for
Thank you.
spending valuable time with our Indian customers. And you can
It
see
was
the
our
kind of
pleasure.
Sure.
interaction that you
It was
see.
really
A lot of
exciting
people
that
are
there is a lot
interested.
of questions being asked. So we're really interested
Yeah.
And
to
a lot of
solve.
relevant questions. Yeah, exactly.
Yeah.
Yeah,
Yeah.
I
Sure.
think we need to come back on the tunnel. There are a lot of questions coming. When are we going to do a fire resistant in tunnel, and what method, what standard that is referring? Because a lot of metro is coming up. A lot of metros are underground today in India, especially the city that I live. So 25 kilometers are the underground. The metro is 25 kilometers, and some of the other cities, so they're much longer. So people are very keen to understand on fire ratings and fire stopping in the tunnel. So we need to have that next webinar on that. Anyway, I'll leave it to you.
Sure.
So sorry, Mrinal,
Sure.
to decide on that. So thank you once again. Thank you, ladies and
Thank you.
gentlemen.
Thank you all.
We'll get
Thank you,
back to you
Dominic.
on that. Thank you so
Thank
much.
you,
Thank
Subra.
you.
Bye-bye.
Thank
Thank
you,
you so much.
everybody.
Thank you. Thank you, everybody.
Thank
Bye.
you.
Bye.
Bye-bye.
Bye. Bye.